Okay, so today we're going to learn about the probability of given events, or another name for this is conditional probability. So we're going to look at this really quick and figure out what this is saying. So what this is saying is it's saying the probability of A given B, or the probability of something happen given that you know this thing is guaranteed to happen. So this is kind of like what we call like guaranteed probability. And if you think back to what probability really is, probability at its core is your chance of winning over your total. So how these events are different is instead of your entire total, they just want the total of B over your chance of winning in B. So it's really just narrowing our focus. And that's why it's written like this. So they're telling you the bottom part is going to be B. So your total is not everything anymore. It's just B. So when I look at this, I'm actually going to ignore everything that is not B. So we're really only going to look at this portion right here. And so when I'm looking for this probability, my total now, instead of being everything, is only going to be 0.6. Because that's everything in this circle. And then when I look at my chances of getting A, I'm not going to include this portion of A because it's not in my circle or in my focus. I'm only going to include this portion of A because this is still A, but it's in B. So that would be 0.2. And then what we're going to do is we're going to divide that and figure out what probability that would be. And so when we divide that out, we're going to get 0.2 divided by 0.6, and that's 33%. Okay. That's the main idea behind these conditional probabilities. Instead of looking at everything, we're going to look at a smaller subset and use that smaller subset to help us find these probabilities. Let's look at some real-life examples. So in this example it says, suppose you have a box of crayons that have the colors red, orange, yellow, green, blue, violet, brown, black, pink, white, gold, and turquoise. And you take a crayon out of a box at random with your eyes closed and say, what's the conditional probability given, or that you draw a green, given that it has 5 letters? So now when we look at this probability, we're not going to look at everything. We're only going to look at the crayons that has 5 letters. So when I look at this, well, red doesn't have 5 letters, so it's out. Orange doesn't have 5 letters. Yellow doesn't. Green does. Blue doesn't. Violet doesn't. Brown does. Black does. Pink doesn't. White does. Gold doesn't. And turquoise doesn't. So then, instead of my total being all of the markers from before, I'm only going to get 1, 2, 3, and 4. So it's 4 over 1. Okay? So that would be my probability, or that rounds to be 25%. Now the next one asks, what is the conditional probability that if your eyes are closed, you draw a blue crayon given that it has 5 colors? Well, again, it's 4, and then we look at our probability of getting a blue, and that's not going to work because blue is not have 5 letters. Blue has 4 letters. So we don't have a chance of grabbing blue. So this would be a 0%. So that's kind of how conditional probability works in like the real world and thinking about things. We know something, so it reduces that set, so our total gets reduced. And then we look at how many times that happens. So even though we have a chance of grabbing a blue crayon out of the box, if we know that that crayon has 5 letters, well then we lost that chance, so it's not in our set anymore. Let's try a couple more examples of this. Okay, so let's say we were given this table, and we're going to use this table for some information. And let's call this the probability of you having cancers. Let's say the probability of C, and let's say the probability that you test positive is a plus. And let's say the probability that you don't have cancer is C naught. And let's say the probability that you test negative is that little negative sign. So that we can kind of like talk about everything and think about everything. So here's the first one I want to do. I want to figure out the probability that you have tested positive for cancer and you actually have cancer. So given that we know that you have cancer, what's the probability that you test positive? So for this one, when I look at this, the probability that you, or the total number of people that have cancer is 244. So that's what's going to go on the bottom. And if you have cancer, the amount of people that tested positive is this 225. So that would be this probability right here. We could do that on our calculator, which would be this divided by this, or 92%. Okay. Let's do, this is like, they have a special name for this. I think this is the sensitivity of the test or something, given that you have the disease, or no, yeah, given that you have the disease, what's the chance you'll test positive? This one's actually a common one. This is called what they call a false positive. So given that you have tested positive, what's the chances that you don't have cancer? And this happens sometimes where you take the test, they think you have it, but you actually don't have the disease. So generally they want this percentage to be really, really low. So let's figure out all the people that tested positive. So there was 4,000 people that tested positive. And it said out of the 4,000, like these are the people that tested positive, 3,879 did not have cancer. So this test is pretty bad, because when you look at that, ,95% of the people that took this test that was positive ended up not having cancer. So this test is actually really, really bad at predicting whether you have cancer or not. So let's do one more. So let's figure out the probability that, you have cancer given that you didn't test positive. And so you also want this percentage to be really low, because if this percentage is high, then you wouldn't be able to, like, the test doesn't give you reliable information. So then when we look at this, we'd say the total number of people that tested no was that 44,626, and then 19 people ended up having cancer. So then we'd say 19 divided by 44,626. And we can see that that number is crazy low. It's not even 1%. So the test is at least good that if you test negative, like, you probably do not have cancer. So this is kind of how conditional probability works and how it's set up. So just make sure, like, when you're doing these events, the given is now your total on the bottom, and this is the actual chance of winning.